Hi, good morning everyone. Today we are going to discussing about another session on computer network. So in this session, we are mainly focusing about this TCP IP reference model. So in the last session, we are focusing about this OSI reference model. So in this session, we completely focusing about this what is TCP IP reference model and what is the difference between this OSI model and TCP IP reference model. What is TCP IP model? So TCP IP in the sense, while we discussing about this connection oriented and connectionless mechanism, we discussing about this many layers are there. We take discussing about this multiple reference models are there. So TCP IP is one of the reference model. So the TCP IP, which means the transmission control protocol, which is embedded with this internet protocol. So the TCP IP model in the sense, which is a transmission control protocol, as well as we are using with internet protocol. So in the TCP IP reference model, we having as a 4 layers are there. But as we discussing about this OSI reference model, in the OSI reference model, we having as a 7 layers are there. So the previous session we discussing about this each and every model and what is importance and what is the functionality of this each and every model in the physical layer and data link layer, network layer, transport layer, session layer, presentation layer, as well as in the application layer in the OSI model. So in this session, we are going discussing about this each and every application and each and every functionality of this TCP IP reference model. So while we comparison this between the OSI model and the TCP IP model, the first model comparison is in the OSI model we having as 7 layers are there, but in the TCP IP we having as a 4 layers are there. So the layer functionality while designing the layer, so the segmentation should be, when you see this one, the network access layer. So what are the functionality we perform in the OSI reference model, which is network layer, data link layer and physical layer? What is these 3 models are functionality performing in the OSI model? The single network access layer is performed in the TCP IP model, which means the same control, same access, same functionality we can able to develop with the help of this only single layer we calling as a network access layer, and this also we calling as a host to host layer. We also calling as a host to host layer, which also a network access layer. And second one is the internet layer. The internet layer, which means, so basically while we discussing about internet layer, while we application perspective, while we developing this host to host layer, so we are implementing with the help of this the internet layer only. And third layer is transport layer. The transport layer is similar to our transport layer in the OSI reference model, which means what kind of sessions we consider, what kind of routing algorithm we are using this one, and all the functionality should be happen same in the transport layer, which is same in the OSI model as well as similar in the TCP IP reference model. And the application layer in TCP IP model, which is similar to the application layer, presentation layer and session layer in the OSI model. So what is these 3 layer functionality is doing in the OSI model? The single layer can do the same kind of functionality, same kind of access mechanism and same kind of network architecture mechanism. So in the down the line, we are going discussing about this each and every model in this TCP IP reference model. What is this network access layer, or what is mean by this OSI reference layer, or in the TCP IP reference model, which means host to host network model? So in the host to host network model, so this is a TCP IP reference model which is equivalent to my OSI reference model, which is a combination of physical link layer, data link layer and network layer in the TCP OSI reference model. And this TCP reference model does not describe the any function of this layer, which means it can able to specify what kind of connection we are using that one, what kind of host connection we are using that one, which means we are able to connect the host must be connected to another host in the receiver section, which means what kind of sending packet we are using that one, what kind of protocols we are using to send the packets from this one station to another station, which means from source to destination. The same can be handled with in the network access layer, which also calling as a host to host reference model, host to host network model. And this model does not define any kind of specific functionality, does not define any kind of specific protocol to be used, because it varies from host to host network model, which varies from this data link to data link layer, or which may be vary from this physical to physical link layer in the TCP reference model. So it also defines how data should be sent in physical through the network, because while we discussing about OSI reference model, where we discussing about the physical layer, the data is transmitted in the form of this zeros and ones formation, which is in the form of this binary formation. That should be same thing happens in the network access layer, which means the data should be sent, data should be transmitted to the physically through the network access medium only. So what is this physically through the network? Because here we are using some kind of physical communication cable between the source and transmission. So the data is transmitted or data is sent through physically medium only. We are using this physical kind of network architecture. And another important functionality, another important response of this network layer, the transmission of data between these two devices on the same network. The data must be present in the same network and the must be present in the two devices. While for example, we're discussing about one-to-one connections or one-to-many connections. So there we data transmitted from this one-to-one system or one-to-many system, which means one source is there and n number of transmitters are there. Similarly here, the data must be transmitted. There must be existing at least two devices. One is source and the other is transmitter. Data between these transmit between these devices, source and destination, and these must be present in the same kind of network architecture. Outside this network architecture, we can't be able to transmit the information. So the source and destination must be present in the same network architecture, then only we can able to transmit the information. But in the OS reference model, we can able to share the information outside the network as well. But in this model, we can't able to do that kind of access scenario here. And the functions carried out by this layer is, which means based upon this datagram packet, based upon this frames we are using that one, and what kind of frames we transmit the network and what kind of IP address to the physical address. So while we understand the simulation of this one, in the data link layer, we also transmit information in the form of this framing structure values only, which means data is in the form of this binary formation, and we are using this one kind of header values and one kind of trailer values we are using this one. This entire thing we calling as a framing sequence. So same way, this IP datagram is transmitted to the frames kind of structure, but here we are integrated with this IP addresses to my physical address value. In this OSI model, we are not focusing about any kind of IP address structure values here, but in the TCP IP model, we are must be present in this TCP IP model in the sense IP address value and physical address value. What is TCP IP? TCP IP in the sense we calling information with the help of this a transmission control protocol with enabling the internet protocol. So here IP address is must be important for us. With help of this IP address, which is integrated to my physical address, then the information is transmitted. That should be in the form of this framing sequence. And here we are using different protocols. We are using that one. That is, we can use this Ethernet controls or token ring or X.25 protocol or frame relay kind of protocols. So here we are using different kinds of protocols. We are using that one. Similarly, by using this OSM also, we are with the layer to layer communication. We are using different kinds of protocol. We are using that one. Similar structure, similar way in this model also. In this frame relay structure or in this Ethernet ring or this token ring kind of construction perspective, we are using different kinds of protocols to able to transmit information from this network layer, network access layer. And the second layer is we also important is which is internet layer. So this internet layer is second layer of this TCP IP model, and this is also known as our network layer. This is also known as our network layer. So what we perform network layer, for example, the network layer in the OSM model, the information is transmitted in the form of this packets. So similarly, here also the information transmitted in the form of this packet. What we performed in this network layer, the same thing performed this internet layer. Internet layer is also known as the network layer. And so here the function of this layer, which is responsible to this layer, which is send the information, send the IP packets, because here the information is transmitted in the form of this packet. This packet which consists of IP address only, which means IP packets only. These IP packets transmit, send the information from this one network and they arrive the destination irrespective of the route they take. Because while we transmit information through internet protocol, so we can't able to restrict our destination perspective. So what is the information we transmitted? That information it may choose the different path which is the shortest path. That we calling as the different kinds of routing algorithm. While we initializing this or while we integrating this routing algorithm, once information is transmitted through this internet protocol, which may send the packet from any network, and the destination array the destination irrespective of the route they take, irrespective of the path they take this one. And so here what happened, so while we taken different path, different architecture here we using that one, so we can't able to restrict the framing sequence manner. Assume that when we have three frames are there, frame 1, frame 2 and frame 3 is there. We transmit information from the source to destination. So here the frame 1 may come first, or else frame 3 may come first, frame 2 may be last. So here we can't restrict the information transmission order. But end of the day, we can able to focusing about this how many frames we transmitted and how many frames we received, and in the ending layer we are going for this synchronization mechanism. So with the help of the synchronization, we can able to synchronize our information in the form of this order kind of structure only. That should be taken care about this next layer values only. But in the transmit layer, in the internet layer or network layer, we can't able to restrict the what kind of order we transmitted in this layer only. But in the same time, in this layer we are using this different protocols, which is IP protocol or ICMP protocol, internet access control protocol or ARP protocol. So different kinds of protocol architecture we are using to develop this internet layer. And next one is transport layer. So the transport layer is which is responsible for this reliability, flow control and correction of data which being sent over the network. Assume that one. So assume that one. In the 3 frames we transmitted, as we discussed earlier, 3 frames we transmit that one. So we are able to transmit frame 1, frame 2 and frame 3. In the receiver section, the transmit section is very fast. We can able to transmit the information, high reliability, right, high transmission speed we are using that one. But in the receiver section, the receiver may be slow to capture the information in that speed of transmission section. So on the situation, frame 1 is received, frame 3 is received, but frame 2 is information is lost. Right. So here what happened? The information is lost, which means we can't able to synchronize in the ending section values only. So the transport layer is taken the responsibility of this, the flow control mechanism. What is flow control here? To control the information of source side as well as the destination side, which means we are able to capture the transmission rate. What is the transmission rate of this transmission section as well as in the receiver section? So we are able to control this flow control mechanism. So which means we can able to reduce the error correction values. So the information is accurately transmitted as well as accurately received. So information is successfully transmitted and successfully received with there is no transmission error. So the reliability should be very high. So that is the reason the transport layer is taking care about this functionality, which means it taking a response of this reliability of my data value. If any errors are detected, so it must be taken care about this error correction mechanism. So while we're discussing of data link layer in the OSI reference model, so data link layer is taken care about this error correction mechanism as well as error detection mechanism. Similarly, in this TCP model, the transport layer is taken care about this, taken the responsibility of this reliability of mechanism, flow control and correction of my data which being transmitted to the network value. And here in this transport layer we are using 2 different protocols. We are using that one. One is user datagram protocol and transmission control protocol. We calling as a UDP and TCP protocol, which means user datagram protocol and transmission control protocol. And this is widely used in, and this transport layer is widely used in the application or a prompt delivery of information is transmitted. So what is the information transmitted? We can able to transmit information. What kind of prompt we are using that one? So deliver data, which this should be important for successful delivery data. We go for this accurate information. We are using data. Accurate kind of information we transmitted with the help of this data. For example, we are using speech kind of things or we transmit any kind of data kind of structure. We are using what kind of information transmitted, how much accurate is there, and what kind of bit error rate analysis of this information. So generally we are in this speech and video perspective, we are using these scenarios. That is a major advantage of this transport layer. And the next layer, which is application layer. Application layer is the 4th layer of TCP model, and this is the last layer, which is a topmost layer. Similarly, in the OSI also, the application layer is the topmost layer, and which means it defines the high level data kind of protocol. The which means it capable response to this high level data protocol, which is the representation perspective. This should be ending of my application layer, which means the web page kind of services in the top layer. What is the visibility of kind of construction? We are using this application layer, and this layer is allows user to interact with the application. For example, while discussing any kind of app, So that should be a user-friendly kind of application values only, user-friendly kind of construction values only. So what kind of, we should be interacting, we should be user-friendly to access the application perspective. That should be the major advantage. So this layer is allows user to interact with the application. So any kind of person, any kind of user can easily interact with the application. They open the app and they can do what kind of services we provided for the application perspective. And this one of the application, when one application wants to communicate with another application, we say forward to the forward, which means what kind of data we transmit forward to the next layer. What is next layer here? The transport layer. For example, we are able to transmit information. For example, typing the word is hello, we are able to send this information. So a user friendly, for example, if you open up on this WhatsApp or Instagram or Snapchat over there, once we are able to interest to send a message, so this message we can able to type in the app, then that information transmitted to the transmit layer, which is transport layer, and next to the our down the layer, which is internet layer, as well as our network access layer, which we calling as a host to layer. So the information transmit, this is acting as an application layer, and down the lines the information is transmitted from this source to destination in this reverse manner. This should be vice versa. So what kind of communication we are using that one, what kind of user friendly scenario we are using that one, what kind of application we are using that one, that is the information is forwarded and transmit to the transport layer values down to the next layer values only, and transport layer to the internet protocol layer, and next to the network layer till to the next coming side, next in the receiver side section values only. And this is in this protocol we are using this hypertext HTTP, which means hypertext transmission protocol, or simple mail transfer protocols, DNS domain name systems, or telnet or file transfer protocol. We are using this different kinds of protocols we are using in this layer. In the next sessions we are going to discussing all these things detail about all the structure values only. So while you see this, what kind of protocols we are using this network and TCP model. So as we were discussing earlier, in this model we are in physical layer, we are in data link layer, and these three things comes to this network layer, which means we calling as a our host to host layer or network layer. At the same time we are using this internet protocol layer. So here we are using this one ICMP protocol or IGMP protocol or ARP protocol. We are using different kinds of protocol to establish this kind of network architecture. Similarly, in the transport layer also we are using two different protocol. One is TCP protocol and other is UDP protocol. And similarly in the application layer, so we are using this, whether it should be a OSM model or TCP model, we are using to implementing this all kind of protocols values only. We'll go for this SMTP, which means simple mail transfer protocol, or file net transfer protocol, or telnet protocol, or domain name system protocol. We are using different kinds of protocol to implementing this our architecture. So here you are able to understand the scenario, which means once we are able to initialize, when we are able to integrate one kind of network architecture, in this architecture we are is n number of layers of presence over here. Maybe should be 7 layer, or maybe should be 7 layers, maybe 4 layers or 7 layers. So once the information transmitted from top layer to my bottom layer, at the same time the information transmitted from the source to destination side. So one is source, another is destination side. So while establishing this acting, this is one kind of network architecture, this is another kind of network architecture. So while implementing this kind of architecture perspective, we are using the different scenario values only. What we using this one, what kind of development scenario we are using, that one, that we can take care of about this TCP/IP reference model. And what is the difference between this TCP/IP model and OSM model? So as we discussing earlier, TCP we calling as a transmission control protocol, and OSM we calling as a open system interconnection protocol. And here we having as 4 layers, and here we having as a 7 layers. And TCP/IP is more reliable because when you go for some kind of physical cable is presence required here, that should be more reliable, and this should be a connectionless communication kind of thing. This should be less reliable. And here we don't have any strict kind of boundaries, but here we are able to using this strict kind of boundaries, because while transmitting information from this top layer to down the layer, we are follow some kind of strict information over here. And this follows the horizontal approach, and this should be follows the vertical approach. While sharing the information or while receiving the information, we need to find out some kind of analysis, some kind of approach mechanism we are using that one. One should be horizontal path, another should be vertical approach. And here in this TCP/IP, both the session presentation layer, it should be application layer, because here we having as a 4 layers are there, so we are merging the layer values only. Here we having a 7 different layer, this should be a different kind of scenario we are using that one. Here we are using session layer, presentation, and application individually, but in this layer the application layer is a merging of the session layer, presentation layer as well as the application layer. And this is develop the protocol with the help of our model. This is developed by the model then the protocol. And another important this one, assurance of delivery packet, because while we go for information transmitted, so it does not provide any kind of assurance of delivery of packet, but this is providing the some kind of delivery of packet. While we get an acknowledgement, there should be a positive acknowledgement or negative acknowledgement. We are getting some kind of acknowledgement services here. It should be give us some kind of assurance of delivering the packet. And the next one, this model layers only provide the connectionless service, and this can provide both the things, connectionless service as well as connection oriented service. And another important thing, this is where is this TCP model we can't able to easily replace. Once we've done the construction, when we've done the architecture of this TCP model, we can't able to easily. But in this model, we can able to better coverage as per requirement. We can able to change the coverage. It should be kind of user friendly kind of architecture over there. Once any kind of layer goes to be a wrong path, we can able to reconfigure that one, or else we are changing the routing path algorithm in the transport or network layer. So you can able to change that kind of different kind of algorithm mechanism in this OSA model. So these are the major differences in TCP model as well as the OSA model. So in this session, we are focusing about this TCP model, which means what kind of services we are using that one and how the network layers architecture is designed. So in this model, we are using these 4 layers are there, and what are the 4 layers are there, and what is the function of this each and every model, each and every layer. And at the same time, we are discussing about what is the difference between TCP/IP reference model at the same time OSA models. So these 2 models are similar reference models only, but while construction, while architecture in these models, what kind of path we are using that one, what kind of layers we are using that one, how the layers is work over there. And here also, what kind of layers we are using that one. If you go for this connectionless communication or a connection oriented communication, what is the architecture of what is the function of each and every layer. So that is a major difference of this TCP model as well as the OSA model. So in the next session, we are going to discussing about what is internet and what is the frame relay, X.25, and what is a frame relay. So as we discussing earlier, so while we designing about this network layer, we are in these 2 different kind of protocols, right, which is X.25 protocol as well as the frame relay protocol. So in the next session, we are going discussing about these 2 protocols, which is X.25 protocol and frame relay protocol. Thank you.